Hi, Spring fans. Welcome to another installment of Spring Tips. You know what I found to be a lot of fun recently? GraphQL. You know why GraphQL is awesome? Because it makes it easy to build client-friendly views of data to support an integration layer for downstream microservices. GraphQL answers a few problems I had with RSocket. I love RSocket for individual services, but when it comes time to expose my services over the network to a particular client, then I'll probably need to work with HTTP. Now, RSocket in turn answered a few concerns I had with HTTP 1.x and even 2.x and gRPC. HTTP 1.x in particular is inefficient, slow, less resilient, payload specific, and inflexible in terms of the message exchange patterns that were supported. So I like these different technologies, and I like that Spring has made it easy for me to approach all these different technologies in a familiar, consistent programming model, that of a controller. I love working with GraphQL because it's an idiomatic approach to GraphQL in terms of the Spring @controller component model. I was talking to Spring guru Rasen Stoyanchev, whose work you may recognize if you've ever used Spring MVC, Spring Webflow, Spring Webflux, the RSocket support, and now Spring GraphQL, among a million others. And by the by, he's worthy of a whole discussion in of himself. I even did an interview with him on my podcast, a beautiful podcast, in which we delve into some of the amazing things he's done. Go check that out. But anyway, he reminded me that Spring's controller annotation is actually a generic stereotype annotation not tied to any particular protocol, not HTTP, not RSocket, or anything else. Spring's stereotype annotations are, to my mind, fairly new. The Spring Framework committer, Mark Fisher, contributed them in version 2.5 of Spring Framework. They're stereotype annotations in the UML sense. That is, they indicate the role of a component in the codebase, which is, by the way, yet another reason why you needn't worry about putting your components in packages named by role, because it's redundant. The annotations already tell the story. It's always been the intention that a controller would be agnostic of a particular protocol. Controllers are the C in MVC, which of course stands for Model View Controller. And it's hard to believe that I've been doing these Spring Tips videos for nigh on 6 years and never done a dedicated video on Spring MVC before. We've certainly looked at Spring MVC in the context of HTTP REST applications. I think I've probably even demonstrated some Spring Web Tier goodness, and I probably have conjured up a Spring MVC view or two at some point, but I've never done a dedicated episode about it before now. One of the reasons is that I never thought I'd have to. I mean, who doesn't know about Spring MVC? Ridiculous, right? Spring MVC, along with Spring's JDBC support, are some of the things that made Spring so appealing way back when Spring debuted in the early 2000s, circa 2002. It's come a long way. At the time, Spring MVC was an alternative to frameworks like Apache Struts, which made the idea of a JSP2 or JSP Model-2 MVC architecture possible and popular. You see, way back in the halcyon days of the 1990s, Sun published a JSP reference doc that laid out two possible architectures for JSP. JSP, of course, is the Java Server Pages specification. It's a hopefully long-forgotten templating technology that relied on the mixing or interspersing of Java code and markup, actual HTML templating markup in the same artifact. It was an easy way to create a tangled, horrible mess, and because it required a compiler to actually turn your template into a Java class, it was also fragile. The first model laid out in this reference document, Model 1, was basically typical of contemporary templating technologies like ASP and PHP. Basically, you'd have a JSP page that contained scriptlets of logic that were associated with that page and that lived in line with a markup. Ugh. It was a thing. I'm not proud. We were there. Mistakes were made, okay? The second possible architecture would become JSP Model 2 MVC. Not because it was, I don't know why it was called 2. I think it's just because it was literally the second option laid out in that document. But the second option was a little bit more elegant. The idea was that you would have a servlet intercept incoming requests and do the work of populating the request and then forwarding that request onto a JSP to produce the output HTML. In this model, the servlet acted as both the model, in that the request parameters from the request were routed to the servlet, and the controller in the MVC pattern, and the JSP page acted as the view. In December 1999, Java World published an article by Govind Seshadri entitled Understanding Java Server Pages Model-2 Architecture. This article clarified the approach a little and made explicit the idea that the servlet would act as a sort of controller in the MVC paradigm, and the model could be anything. A vector of data, an EJB, the match was lit. Craig McClanahan built the first version of struts around this time, formalizing the distinction between model, view, and controller. Action forms would be the model in this struts world, actions, the controllers, and templating technologies like Velocity and JSPs, the views. I loved struts, right? There's a lot of interesting activity around that because it was the first time that we had a clear-cut architecture for building successful, scalable applications on the JVM. And at the time, by the way, when we talked about what would satisfy the role of your model, well, at the originally the discussion was around EJBs. But then we discovered after a while that you could probably get it done with just Hibernate, right? And you didn't really need EJBs. You could actually do a lot of interesting stuff with just the web framework inside of Tomcat, not inside of an application server, and some sort of data access layer. So Apache OJB, MyBetis, or iBetis, Hibernate, JDO, all sorts of things were equally as interesting. And Spring came along and made the possibilities even more concise with the smart support for JDBC and so on. So struts was really empowering because it meant that people had a template they could follow to build applications that would survive scale, and it just ran in open source Tomcat, or at least very lightweight containers like Tomcat. You didn't need a full-on application server if you didn't want it. Struts did for Java what Ruby on Rails did for the Ruby community later on. Now, Spring was born in 2001, so this is a couple of years after struts would have been around. The earliest code in Spring, if you check the Java docs by date, has to do with HTTP web support. There was even an integration that made using Spring and struts together as easy as can be. You could use Spring to manage your action beans. What a time to be alive. It was really cool. I actually really enjoyed that particular integration. Spring MVC was developed and included in Spring Framework itself because it was considered so vital to Spring's value proposition that, of course, it would evolve along with Spring itself. And evolve it did. The original Spring MVC relied upon concrete base classes and interfaces that all MVC components had to implement. When Spring 2.5 introduced an annotation-centric component model along with the now ubiquitous stereotype annotations, it started the process of jettisoning those concrete base classes and embracing a completely POJO-centric and declarative framework for building HTTP endpoints, all rooted in the @controller stereotype annotation. A few years later, in Spring 3.0, Spring MVC debuted proper support for building HTTP REST endpoints, building upon essentially the same component model. So Spring MVC is still one of the most popular modules in the Spring ecosystem, even if people aren't building MVC Model 2 applications as much anymore. Indeed, today's Spring MVC applications are using the HTTP REST support, right? Spring MVC is a workhorse for building Spring MVC-based HTTP REST applications. And instead of building server-side HTML views, they're probably building rich clients in the browser or your typical iOS or Android or clients and connecting those clients to HTTP REST endpoints or now GraphQL endpoints on the server. All of that is really exciting because it means that there's now a new role for Spring MVC to play. But in this video, I want to kind of revisit what it looks like to build a web application, a Model-2 MVC kind of application using Spring MVC, where MVC was what you were going to do with it, right? Obviously, we're going to look at other ones here. In fact, this is just the beginning of a small series where we look at different uses of @controller, because I think it's really quite compelling what's possible in the Spring ecosystem with but one little annotation. And once you've understood what's possible with one implementation of that annotation, you'll be surprised at how many doors open for you when it comes time to build these other kinds of applications. So let's dive right into it. All right, let's go ahead and build a new Spring MVC application using the servlet stack. So we'll call this an MVC. I'll be using Kotlin. We're going to bring in the web support and we're going to bring in the Timeleaf view templating engine. We'll hit generate and we're going to open this up in the IDE. All right, let's load this up. And in the root of the project, we have our source main resources templates directory. Okay, that's where we're going to put our Timeleaf templates. We're going to build a controller, and we're going to call this the greetings MVC controller. And here, we're going to have an endpoint that returns a view, a template, right? When somebody goes to greetings, right? Let's say greetings.html. It's arbitrary. It could be greetings.asp, right? It doesn't matter, right? Greetings.xhtml or whatever, or .do. Do you remember for many years there was struts and the convention was to use .do? So this is the URL, right? And then we're going to say, when this gets called, when somebody makes an HTTP GET request to a URL ending with greeting.do, we're going to return a model. And this model is going to be kind of like a key value pair. It's a dictionary that contains information that should be rendered to the client in the template. So we'll say model. We'll say model.addAttribute greeting. I'm going to pass in a greetings object here. Now we don't have a greetings object, so I'll create that right now. Var name string question mark, okay, equals null. So it can have nothing or it can have a field. And then we're going to return a value. We'll say return, let's just call this render, okay? We'll have a view logically named render. What that means is that we're going to need to go to source main resources templates and create a file called render.html. And for render.html, we'll have a form so that you can fill out some data, have it submit, be bound to a Java object in the request, and then make it made available for the controller handler method to process it. In this case, we're using timely tags. So you saw I just pasted in the HTML template for the render page. So what this is going to do is it's going to render an HTML form. The form will call greeting, what do we call it? We called it greeting.do. Okay, so it'll go to that endpoint. And by the way, the reason you have this special syntax here is because it'll actually resolve the context path if you're running inside of a servlet container or something like that. Then we're going to say, when this form gets submitted, bind its fields, its constituent form fields, to the properties or the Java fields on the object, the object's properties. So the object in this case is what's in the model, which is called greeting. So we have greeting. It's an empty greetings. It's got a setter and a getter for a field called name. And we're going to say that we accept a post. And then we're going to bind the contents of this input text field to greeting.name. And then we can submit. Okay, so that's the post side. Let's go ahead and run that and see what we get. Okay, let's go here, localhost greeting.do. All right, so that's worked. We've got a field, but nothing to submit to. So let's go ahead and add that now. We'll create a new endpoint that responds to a post for the same URL, right? Greeting.do. And here, we're going to say post, right? We're just going to call this handler method post, and it's going to return a string, and it'll accept a form value of type greeting. Okay, greeting. And the model will be model. Right, so we're gonna use the model to populate the data that gets sent back to the client, but to process the incoming data, Spring MVC is nice enough to convert the form data into a Java object or the Kotlin object, in this case the data class called greeting. So we're gonna return post, okay, and we're gonna add an attribute here. We'll say add attribute, and it'll just be another greeting just like before, except this time we're gonna send the result directly right back. Okay, nothing fancy, we're not doing anything with it. We can say println processing incoming greeting. There you go. So now you'll be able to see that this is actually happening. And we need a new template here, a new file called post.html. And we'll paste that template as well. There we go. So we're going to paste that template as well. Okay, so we'll paste that template as well. And here we're just saying render the page with the object in the model attribute called greeting, render the field called name in this, just a text element, just a span. There's no form field or anything. We're just printing out data that was given to us from the server side, right? So in the render case, we're rendering a default form. We're doing basically nothing with the incoming requests. Here, we're rendering the data after it's been given to us. We're rendering the same data as a view. Okay, let's try this. All right, so now refresh this. This is greetings.do. We're going to say Spring fans. All right, submit, and there it says hello Spring fans. So we've just built a simple MVC, flow. Right, the model gets submitted via a post from that original page, which I get to by going to making an HTTP GET. The model is populated, it goes into the server then responds to the data by adding it to another model, and then printing out, processing incoming greeting, and then returning to a different view. All right, now, a couple things. What if I wanted to actually have data, on the first load? What if I wanted to pre-populate that data, if it's possible, based on the presence of it, right? Well, I can do that using a request param. So I can say request param name string, okay? And here I can say, okay, this is nullable, right? And it's not required, so I can say required is false. And here I'll say if name does not equal null, then this one, else no name, right? Very simple. So there's my default flow. Let's try this one now. Okay, so now just refresh this, no problem, it works just fine, but name equals world, and there it gets pre-populated out of the box. Not bad, huh? And then I can submit that and I can say hello world. So you can see that Spring MVC makes it really simple to build HTML views. And of course, I'm using a view resolver here for time leaf, but you can use any kind of content type, right? You can actually you can generate spreadsheets, Excel spreadsheets, and PDFs, and you can generate all sorts of different things, right? There's all sorts of different content types that can be served from a Spring MVC endpoint. You can create images, right? Dynamically write the bytes to create a JPEG or something and then send that back. Anything is really possible at this point. Okay, now one thing I want to take care of course, is what happens if there's an error, right? What happens if we add a name to the incoming data and the name isn't capital letters? Well, of course, in this case, I want to do some validation, right? So at a minimum, I'll have an assertion, right? Assert dot is true, and I'll say character is uppercase, greeting dot name dot car at, and let's see, 0. Okay, let's see. The name might be nullable, so I say that, and I'll say that, actually I want the first character, okay? So if that first character is capital letters, great, otherwise I'm gonna throw an exception. The name must start with a capital letter, okay? Now what happens if that throws an exception? Well, I wanna have some handling to make sure that I do the right thing. Now you can do this a number of different ways. You could actually have a try catch in the handler method itself. You can actually create another thing called an exception handler in the class, right? Exception handler. And you'll see that exception handlers are pretty common across all the different controller implementations. And so the basic approach is you create a method that looks like any other method, there was an error, and exception utils dot, oops, nope. What do I want to use? I want to use, let's just do this, ex stack trace or message. There you go. Let's just use the message, okay? So you create a method that looks like any other handler method, but it only gets invoked when there's an exception, right? And so here I'm saying I want to resolve any exception. You can be very specific about it. You can say I want to resolve only a legal access error, that kind of thing if you want. And then this, of course, would be down type to that. And if you don't care about the method, if you don't care about the exception, you don't care about it using or getting a pointer to that method, to that exception. If you don't care about getting access to a pointer to that exception, then you can just declare the type that you want here and then omit it from the signatures. But I care, so I'd rather just do that. That works fine. Okay, so now I'm throwing an exception when I am submitting anything where the first name is not a capital letter. Let's try that. Okay, refresh. Let's say Jane. Okay, throws an error, right? You could, of course, do visual validation here as well, but I just wanted to show you that you can easily center your exception handling logic. You can go a step further. You'll see that this is pretty common across all the different controller implementations, where I want to say exception handler controller advice. All right, and here you can create, just copy and paste that same thing. So there you go. So the controller advice gets invoked for generic things like model binding and exception handling, but not for actual routes, not for resolving the views, right? So let's restart. And same basic flow, lowercase Jane, exception, there's an error, must start with a capital letter. So this can apply to all controllers. This is a kind of a way to introduce common behavior across all the different controllers. You could even go a step further. Here I'm just doing void, but you can actually have this return a view or something like that. And so you can actually populate a view page. You can also listen for things based on what the exception handling and all that stuff. You can actually inject the current request. You can produce a response status. You can do all sorts of amazing things with exception handlers. What you can do, of course, varies from one protocol to another, but it's nice to know that you can. All right, good stuff, huh? We looked at how to use Spring MVC to build MVC applications, as in Model-2 MVC. Now, obviously, this is but one application of @controller, and it's arguably the oldest and, possibly even the least used today. I don't know, I have no idea, but Spring MVC is certainly used a lot. It's still by far the most popular web framework in the Java ecosystem. But these days, as I said earlier, it's a workhorse for REST applications. So it's very interesting that you can still build this stuff. And other frameworks have actually gone the other way. There are other frameworks out there that built a REST framework, but then realized they also needed to support MVC-style applications, and so they grafted that on eventually, right? So we did this the other way around. We supported MVC when it was popular and appropriate to do so, and then we added REST support to the same framework. And this meant that if you had a conceptual model for one, you could easily apply those skills in the other. This is one of the things I love about Spring, is that you get rewarded for investing a little bit of time and learning the approach, because that idiom, that muscle memory still works. It still applies in these new contexts. In the next videos, we'll look at things like GraphQL, HTTP REST, reactive web applications, WebSockets, and RSocket. And then we'll look at some things that only apply when you start to mix and match these things in the same application. As always, thanks for watching, and we'll see you next time.